So morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Great, thank you for confirming, everyone. So, my name is Neeraj Kheria, and I have been working in this IT industry for more than 13 years now. Before we proceed further, let me quickly introduce our Edureka Masterclass community with you all as well. So this community of master classes was started back in 2019, and since then we have been closing into almost 32,000 members so far. And in these master classes, we have been conducting multiple webinars on different topics, including blockchain, IoT, artificial intelligence, machine learning, big data, and multiple front-end and back-end development technologies. And the best part about these webinars are they are absolutely free of cost, so there are no charges involved here. And these webinars are a really great platform for anyone who is looking to get into this industry vertical by learning the technology that they are interested in. As a part of our discussion, we are going to discuss on the climate change and how exactly that is structured. So that is what we are going to focus on as we proceed further. So first of all, we are going to talk about the principles of the time series analysis, what exactly it is, and then we are going to proceed further into the hands-on. So first of all, here we are going to look at what exactly is time series data, what is time series analysis, time series use cases, about the project, why does stationarity matters, and environment and tools for the project, including the hands-on. So if you talk about time series data, then what exactly it is? It is a collection of observations obtained through repeated measurements over time. And it also referred to as timestamp data is a sequence of data pointers indexed in time order. So for example, we can see here we have a data for a website visitors. Like for example, how many visitors are there for a month and then in the park, and what exactly is the temperature, the average temperature recorded here. So you can see here we have the number of visitors per month, then we have the timeline, and then we have the average temperature recorded for the Yellowstone Park as a part of a time series based data. So what exactly a time series analysis is? So if we talk about the entire analysis, and time series analysis is basically a statistical technique that deals with time series data or the trend analysis. So the time series data means the data is in a series of particular periods of intervals. So there are going to be multiple use cases for time series that we are going to talk about as we proceed further. Just a moment. So in terms of the use cases, so there are multiple use cases for time series, like we have for financial services, for weather analysis, for network data analysis, for healthcare analysis, and so on. So now someone may have a question, okay, what exactly makes it special? Because see, time series is a collection of data pointers collected at constant time intervals. And these are analyzed to determine the long-term trends, so as to forecast the future or perform some other form of analysis. But what exactly makes a TS different from, let's say, a regular regression problem? So there are two things. So time series is time dependent. So the basic assumption of linear regression model that the observations are independent doesn't hold in this case. And along with an increasing or decreasing trend, most TS or get to the time series have some form of seasonality trends, that is variation specific to a particular time frame. For example, we can see the sales of a woolen jacket over time. You will invariably find higher sales in winter seasons. And because of the inherent properties of the time series, there are various steps involved in analyzing it. And they are going to be discussed on how exactly we can work with. And we can work with the entire analysis based on Python. So we have multiple use cases. For example, let's say here we are talking about stock market data of 2020 from Kaggle. So Kaggle is one of the primary data sources where we can get data for almost every kind. And some are available from the official APIs from the companies itself. So basically here we have the access to multiple data sets, which can be from the we can find data set for aviation, for banking, for e-commerce, for the normal analysis based on any entertainment industry as well. So these all things can be defined. All right. So we have classification. So we have data set for almost every industry. For example, for COVID, for economics. For economics, we have the country, region, and world GDP. We have world happiness reports, supermarket sales. We have for education sectors, healthcare data. We have for different image, we can say image data for visualizations, for NLP, for arts and entertainment. So we have all the data set available, and we can go ahead and explore that. Now, this is a good repository where we can find, as you can see, almost 80,000 data sets are available for different use cases that we can make use of. So here we are going to talk about stationery. So first of all, let's talk about why does stationery matters. So why does stationery matters here? So basically, most of the time, most time series models assume that each point is independent of one another, and the statistical properties of data should not change over time. Stationary helps us better identify the driving factors as well. Like we have the stationary time series, and then we have a non-stationary time series as the same data set is being used in these two different graphs. And then we have environments and tools for the project. So basically here we do need to have the access to NumPy, Pandas, Matplotlib, Datetime, and Stats model. So these are the libraries required here, and we are going to work on Python programming language. So now as a part of the hands-on, we are going to work on the same file that we have the access to, and let me just guide you on how we can work with it. So this is a notebook file that we have currently opened up. So here we have to first of all import pandas as PD. So first of all, we are working on Colab. If you're comfortable with your own local Jupyter notebook file, then we can make use of Jupyter notebook, or we can make use of the other notebook file as per the requirement. We can do that. And for now, we are going to make use of Colab. So Colab doesn't have any kind of hardware requirement. In case we don't have the access to a high-end system, or we are experiencing a low performance in our own system, then we can go ahead and make use of Colab. It's like an online notebook available where we can code on top of Python. So we can define the libraries that we are going to make use of. So first of all, we have to import pandas as PD. Then from datetime, we are going to import datetime and time date. Then we are going to import matplotlib, which is basically used for visualization part as PLT, then NumPy as NP, and then we have stats model to work on the statistical models here, and then Seaborn, which is basically an advanced visualization tool offered, just like we have matplotlib, and then we want to use inline. So this line is being added here because we don't want to see the graphs being opened up in a different window. We want them to be showcased within the notebook itself that we are going to work with. And then we are going to import on warnings because there are sometimes some warnings are going to be shown based on the data set and the method that we are going to make use of. Now we don't want that, so we can simply go ahead and import warnings. All right. So first of all, before we start, we have to load these libraries, and then we have to go ahead and run it. So for running the statement, we can simply click on play, and this is going to run the statement for us. If we are going to work on a, we can say a visualization heavy application, then there we can make use of the GPU-based instance here. All right. So basically, in case we want to change the runtime, we can simply define change runtime. And suppose here we want to focus on GPU-based instance. In case we are going to work on multiple visualization tools, then we can make use of GPU-based kernel. And again, as you can see here, now again, the computer engine is currently being refreshed. We can execute this again. So all the major libraries required have been created. All right, so once we are done importing these, then we are going to work on reading the CSV file. If we have a global and temperatures by state .csv. So this is basically a data that we have the access to. So in case you are going to work on Colab, so here we can simply go ahead and import the dataset. So here we have folder by the name of workshop files, and within workshop files, we are going to upload the temperature, the global land temperature file that we have the access to, because we are going to work with Colab, right? So for Colab, we have to make sure that we do add the drive link, then only we can connect. If in case we are doing this locally, then there's no need to connect. There's no need to upload our data on Google Drive. We can define simply the local path. But again, before we can work with it, we also have to mount our Google Drive with this notebook file in case you want to work on Google Drive as well. So here we can click on mount. So basically a code is going to be inserted here. which will say from google.colab we are going to import drive. So first of all, we have to authenticate that yes, we want to use our Google Drive from this account. We have to allow it, and once we verify it, we have to get the authorization code, and this code is what we have to enter here. In case we are going to do this locally, then there's no need of mounting this. In case you want to work on Google Code, you can say Colab Drive, then only we have to use it. All right. So here we can go ahead and, so as you can see here, the drive has been mounted. So now we can define the path. So our content is available under content, drive, drive, and then under this we have my drive, and under this we have a folder. So we have a folder by the name of workshop files, workshop underscore files, and then under workshop files we have the file name by the name of global LAN change. So this is a file name that we have to enter as global LAN temperature state by state dot CSV. So this is the file path that we have to define. All right, so we are going to make use of df. So again, pd as in pandas. So using pandas, we are going to simply read the content of this file. So we can run the statement here as well. We can run it, and you can see the statement is currently being executed. And now if you want to show the head, that means the first 5 rows available in this sheet, and here we can simply run the statement here, and here we have date, average temperature, uncertainty, and then we have state, and then we have the country. All right. So now if you want to see the types here, we can simply run the df type. So you can see here we have the objects, and then we have the column, and then we have the data type defined for these different columns. All right. And then we can go ahead and print the shape. That means how much of data we have. And then we can simply print if it is null, then what should be the sum of the values. And then we are simply going to represent the first 5 rows in terms of the first 100 rows being returned as a response. And now we are going to define the name. So here we are going to rename certain columns as DT to date, average temperature to average temperature uncertainty to confidence interval temperature, to make sure that labels are more aligned to what we are trying to achieve here. And then once we have changed this, we can see now this was the other heading, right? The other main column, and again here we have the change heading. And now we are going to make use of the same date to date time. So here we are going to convert this column into date time format itself, and then we are going to set the date, and then we are simply going to print the df index. So next we are going to simply define the different temperature changes. So we have latest differences in terms of the countries, the average temperature. We had a group by country, and then we are going to simply find the average, and then we are going to sort the values based on average temperature. As you can see, the lowest has been for Canada, then we have for Russia, US, China, Australia, India, and Brazil in terms of average temperature being defined. And then we can simply plot this on a graph as well, where we have the figure size as 94, and then we are going to simply import as 9 for different values. And again, here we define a simple plot show. So this entire graph is going to be plotted by using the same plot library that we have created. But again, before that we can do that, we have to ensure that we do run all the other data frames as well, because again, we have to make sure that we do create the data frames, we do go ahead and import all the data types as well. Then only we would be able to make use of it. All right, so here we are simply going to create a new data frame where we are going to find the latest data frame as well. Suppose we want to create a temporary data frame from 1982 2013, and we can simply create a new data frame out of the existing data frame that we already have the access to. All right, and then we are going to create the latest difference. So in terms of latest difference, we are going to define the country and the average temperature based on the new data pointers that we have created as average temperature. So this is going to be a new view that has been defined, and then we are going to create a new graph from the same latest view. As you can see, this is the latest graph that has been created, and then we are going to simply work on resampling as well. So after resampling, we have simply resample based on the parameters as a, and then we are simply going to simply define the resample parameters. And then we are going to plot the resample plot by using the matplot library, where we have defined the title as this one, figure size, and then we are going to simply plot temperature and year. And we can see it has been continuously on a rise only. It has been increasing on a per year basis. And then we have the other components. Now, let's suppose here we are looking to compare the changes in 50-year slots. For example, we want to see how the change has been in last 50 years. So for that, we are going to compare the timeline in terms of this time series analysis. So first of all, we have to use a resample data frame. And then from that, we are going to exponentially find the weighted mean. And then we are going to roll standard deviation. And then we are going to create a subplots next to each other. And then we are simply going to create two different graphs here, temperature graphs with rolling mean and exponentially weighted mean as well. And then we are going to create a temperature graph with rolling SCD, where we get to find the temperature changes from 1980 to 2013, and this one is from 1980 to 2003 in terms of the extra. And again, as you can see here, this has been the changes from 1980 to 2003, and what exactly has been the original, and then the rolling mean and the exponentially weighted mean, and this one how exactly has been the rolling SCD as well. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye bye.